let's start with the fact that the world changes. The world is always changing. We've put up many diagrams that assume we're in a stable state. That's the wrong assumption. It's always changing. Moments of quiescence penetrate a normal array of change, and many of the things that we think of as creating success drive and accelerate that change. We live in a changing world. Remember, right? Any of you watch Mad Men, right? Technology was supposed to create more leisure time. Instead, we are in 24-hour productivity land. Second, the world doesn't work the way you think it does. Period. Right? Our models are incomplete. This is a found sign. The system was never broken. It was built this way. Snafu was normal. Snafu is the normal state of systems. You all know what snafu stands for. Situation, normal, all effed up. And by the way, remember, it was coined by the grunts on the side that was winning the last war in Europe. Right? That's how, this is the normal state of systems. Now, this is not a pragmatic statement. These are actually core theoretical statements that launch our inquiry into how systems adapt and how they fail to adapt. Right? Our topic is adaptation. Our process is processes of adaptation. Right? It isn't simply about external events that degrade services. Right? It's how we adapt in the face of change. Now, people are an adaptive agent. Right? Systems of people are adaptive agents, but people are not the only adaptive systems. In biology, we are starting from a biological sphere, and we can't explain that if we can't also explain the human sphere. In all of these, right, our poster child of adaptation is actually people. People are not the source of failure in systems. Right? Our systems are have inherently brittle points. Failure is due to brittle systems. Right? Systems work better than they are supposed to, right? Because people, some responsible people in some roles adapt to fill the gaps and shortfalls. A system does what it's designed to do. It's just not what the designer intended. So let's step up a level. We have to think about this make a conceptual leap. I don't care what kind of plan you have. I don't care how good it is. I don't care how it's been tailored to learning about a variety of variations and changes and challenges in the world. We develop a variety of things we're going to summarize as some kind of planful approach to control, in a neutral sense, right, what goes on in the world. And so we look at the world through the eyes of the plan, the frame of the plan. And what do we see? It's only by accident that it was a lovely tree. I didn't mean it to be an ecological system for this context. Whoops, it doesn't play the animation. Oh, I forgot, with PDFs it doesn't play the animation. The dragon's supposed to be moving. So damn PowerPoint screws things up when I can't use Keynote. So looking through the plan, you only see part of the world. And what you miss is the fact that there are other agents stepping in to fill the gaps. Snafu is normal. There are boundaries to any plan, and the world will challenge those boundaries with the dragons of surprise. So somebody is off taming those dragons, right? And this guy doesn't appreciate that there's dragons or dragon taming going on. That's actually called the Fluency Law. How many of you heard of the Fluency Law? Well, if you're going to play in this field, you should know what the Fluency Law is, right? Well-adapted activity hides the difficulties handled and the dilemmas resolved. Adaptive behavior hides what it's adapted to. From a research perspective, studies of adaptation uncover what, right, units of adaptation, adaptive systems at any scale have adapted to over time. Now, there's breakdowns in that, right, and there's successes in that. Right? Meanwhile, the person taming the dragons is looking back at the person admiring, enamored with how beautiful their plan is and how great the world would be if everything worked according to plan and the world would just change to fit the plan. Meanwhile, they're going, how about a little help over here? Right? Think of your first responders and interview them about all the stuff you're talking about in terms of organizations all the way up. And we can talk about story after story about first responders being left in that position of taming various kinds of dragons of change. Right? Dragons that surprise, that challenge at the boundaries. So we are stuck with, and our motivation is how to deal with crises of complexity. The things we do as adaptive systems, As adaptive systems, we do things that create a more interconnected world. Right? It creates crises of complexity. Our successes create complexity and crises of complexity in networks of extensive and hidden interdependencies. Failure is due to brittle systems. So I'm interested in the word resilience, which I will now throw away, right? Because it's completely polluted and unhelpful, as the last 2 days illustrate. I'm interested in the problem of understanding brittleness. What's brittleness? Descriptively, brittleness is really simple. Right? It's obvious to us all. There's a boundary, right? No matter what kind of system, no matter what kind of scale, no matter what kind of quality of plan, learning algorithm, technology, automation, drone, I don't care what, it has a boundary. And what happens when events challenge those boundaries and the assumptions that generate those, right? Its performance falls off rapidly. Gracefully degrading systems, as was mentioned, fall off gradually when at the boundaries, right? What happens in the biological sphere? They don't survive very long if they don't gracefully degrade. If you're brittle at the boundaries, you won't survive. Now, the problem with descriptive definition of brittleness, it's not actionable unless you take surviving, right, as your measurement. And in genetics and evolution, we can do that. We can't do that in human ecological, human social, socio-technical systems. We have to have a different way to think about brittleness, right? But right? Systems as designed are more brittle than other perspective stakeholders realize, but they fail less often than they should, right? Because some people are filling the shortfalls to stretch the system in the face of smaller and larger surprise that are ongoing and continuous. Surprise is normal. The dragons show up. All right, so where are we? We actually are in way better shape than this 2 days has told us. Why? Because ultimately I'm an empirical scientist. I'm standing up here talking about where the theory is going, but really our success comes from studying adaptive cycles, histories, right? Last night's lecture was a history of adaptive cycles, an extremely broad account of a variety of kinds of adaptive cycles, right? A fundamental skill we bring, if there's any meaning to this as a field, is to study adaptive cycles. Now, we just heard one of projecting adaptive cycles, and that was wonderful. Now, you don't have a mechanism for charting the adaptive cycles, right? But that's what you were doing with your simulation. Wonderful stuff, and absolutely fundamental if this has any sense of being a field. This is our bedrock. We look at, collect, share, analyze stories of brittleness in action, or its opposite, which I won't call. I won't use the R word. And we extract general empirical patterns. Now, when we do that, we discover that our present is way more precarious than anyone realizes. And this is actually a general finding from organizational, cognitive, and several other scientific studies. We see it over and over again. We have different words for it from the different disciplines. But in all of these, we are more precarious than our record of past success would suggest. All right? But we don't realize that. And we'll talk about how we understand where it's brittle. There's trade-offs in how this works. There's basic ways adaptive systems break down. And we have to project how change produces unintended consequences. That opening cartoon I use, which we haven't talked about at all, unintended consequences of change. And our question is, can we build in the properties that escape brittleness? The irony in this setting is I have to use escape brittleness because usually I can use resilience or a synonym, but here it's impossible. I have to stay with the double negative, I guess, here. It's driving me crazy. So in my community, what do? We extract general patterns from these. Think places like intensive care units, emergency rooms, or even the interaction of intensive care units and emergency rooms. We study it in automation and aviation, asymmetric lift and airplane crashes. Something very relevant to icing and flying to Aspen. Business critical digital services, high frequency trading, the changes in that market. So here are some basic findings. The scale at which this is successful, that we understand what's going on, we see tangible experience with surprise, unease about precariousness, initiative, decentralized and coordinated initiative, reciprocity across rules, units, and levels, graceful extensibility. So I've got 37 ideas in here. I don't know how many you had last night. You said you had a lot. I have 37. Wow. I hope you remember 2 or 3. One is graceful extensibility, right? Now, before I introduce that, remember, the thing we have to explain about complex systems is this. Complex systems have a paradoxical finding. They become more optimal under productivity and efficiency pressure, faster, better, cheaper pressure, but when events fall outside that envelope, they suddenly fail. They're brittle because they have insufficient graceful extensibility. Graceful extensibility is the property, it's an active and positive property, not simply fault tolerance, to act in anticipation of exceeding those boundaries. Right? When you see the signs you're getting close to the boundaries, that the dragons are changing, they're no longer blue, right, and breathe fire, right? They now start to be a different color with a different risk. You start noticing that change and you can adapt how you work. So graceful extensibility is a property that we can actually study in these systems, and it has to be there. So here's a quick list of a whole bunch of things you should know about. Decompensation, graceful extensibility, risk of saturation, fundamental trade-offs. I just want you to remember adaptive cycles, you brought up. All of those could be a half-hour introduction. So let's do those. We're just doing those 2. So hits so I want you to, well, there's another one, the Fluency Law, graceful extensibility. So I want to do, there's 3 basic way all adaptive systems fail. There's 3. Empirically, we may find more, but at least these 3. Universal ways they break down. I just want us to talk about the first one. We're already talking a lot about the second one. Decompensation. Decompensation. Breakdowns occur when challenges grow and cascade faster than responses can be decided on and deployed to effect. That is the final common pathway of failure in all adaptive systems. They all end up failing that way. When you work across purposes and can't synchronize across groups, silos, and fragmentation, ultimately it ends up in decompensation. You can do this in urban firefighting, where we study this. We would be nice to have a talk about how we do these studies and what are the empirical techniques we should be formulating, because it's hard to pull off. But here's a simple one. Look at failures, look at successes. What do you find? If you request resources when the need is definitive, it's already too late. That's what the incident commander says. What's that? The risk of decompensation. They anticipate bottlenecks ahead, generate resources to deploy, right, in order to avoid that situation. Saturation, the risk of saturation. So what's decompensation? It's important to realize this is a pattern that exists across scales. The heart does it. It's called the Starling curve in cardiology. Automation does it. Asymmetric lift. Groups do it. Surge capacity in the ICU. It's going to take 7 more minutes. High-frequency trading. Critical digital services. Here's the night Capitol collapse in 2012. What does decompensation translate to? You're slow and stale. You can't keep pace with the change of events. That's a breakdown in adaptation. It happens, notice, those are all different temporal scales. There's a positive side, so let's go back and end this. I was getting to the ending. It's the last 2 slides. So the questions for the group, if you start to look at this kind of body of material, right, which I've just given you a quick pointer to, is how do we reinforce the search for general patterns? How do we get that empirical dialogue going? Right? I didn't see any of it in our discussion so far. The potential is there. Comments about some great reports that had lots of cases, some things you were bringing up. We're making hand waves to some of this stuff. We need to be able to better share this, and we need new tools to map the adaptive cycles and share the results, because right now they're very difficult to communicate. Second, all right, here's where we need our risk analysis. It's a risk of adaptive breakdowns. Right? It's about how adaptive processes fail. Right? And the last one is we haven't talked about trade-offs. If we're going to build a resilient future, we have to understand the fundamental trade-offs, one of which is optimality, brittleness. The more you pursue optimality, you will move around and increase the points of brittleness. How do we overcome that? So let me end with this. The adaptive universe that we all live in has basic rules. They're not what you think. In this 2 days, we've already fallen back into oversimplification tendencies over and over again. does not work the way you think it does. It really does have basic rules. We can and are figuring them out. In adaptive systems, yesterday's solutions, right, produce today's surprises, which become tomorrow's challenges. That is a dynamic, ongoing. As the biologists say, the struggle for fitness doesn't stop. Thank you.
Thank you. Let's have some, yeah, right there.
So, just two quick questions. So, the first one is brittleness. Totally agree. That's the K phase of panarchy. And so, just in terms of thinking about it, just your thoughts on that. But then the second one is, can you compare contrast graceful extensibility with Schumpeter's idea of creative destruction? And so, how do those two fit together?
Okay. So, on the figure eight, I think the figure eight is great, but way too general and way too pessimistic. And so if you read the How Adaptive Systems Break Down, my opponents are the pessimists, which would be people like Chick Perot, Diane Vaughan, who basically think we're trapped on a trade-off curve, which is we can be really efficient and then we'll have sudden failures due to complexity effects, or we can back off, have less dramatic failures, but we'll be less efficient and productive, and we have no choice. And Doyle and I are optimists. So I think your figure eight is too general and too pessimistic. So that's the big answer. Decompensation happens at all scales, and it's a process we can look at from all the way from basic control theory through all kinds of social systems. So I think for a variety of reasons, at least it's a unit of analysis back to if we take it as an empirically driven process, driving our theory and exploration of how adaptive systems work and fail to work. Now, what was the second one again?
How does graceful extensibility relate to this idea of creative destruction that has been used in lots of contexts?
Okay. I don't like creative destruction because in practice it ends up just being the destruction, and it's a wing and a prayer if anything creative happens. So what I talk about is fluorescence. Right? That in adaptive networks, what we don't study is processes of fluorescence. So that's the other phase in your figure eight, right? Which is, and so I teach it as things fluorescence stall. And we have a variety of processes of fluorescence stall. So if we look at the Google of history, you can look at it as a succession of fluorescence and stalls. Fluorescence is a process across the network where seizing opportunities at one node in the network creates opportunities for other nodes who seize on those in ways which now create opportunities for other nodes, so that you see a rapid transformation. And if you think of the history of Google, there's been at least 3 fluorescences in the history of Google. And so my students chart adaptive cycles around charting these sub-processes rather than the general figure eight.
Billy? There's no time for an answer, but Billy can make it.
Yeah, no, just I want to take you back to your slides on the plan.
Yeah.
And if I understand it correctly, it seems, and maybe I've got it wrong, but it seems that you're looking at the plan in a very kind of static manner. However, now in applied practice, the plan preparation and delivery is very dynamic.
Yeah. So this is the key point.
Panoramic.
Yeah.
And
Key
it's
point.
really delivering a
No.
more holistic
And the
approach.
answer is we do take that into account. It's in the latest theory paper, and the answer is it doesn't matter what kind of plan. I don't care how automatic it is. I don't care how dynamic. I don't care if you put machine learning in it. No matter how you improve the plan, it has boundaries because it has finite resources, and the world continues to change. Therefore, the plan will confront the dragons of surprise. It will break at the boundaries, and you must have some ability to gracefully extend performance. Otherwise, you'll be too brittle and fail.
But proper planning, bringing in all the thematic areas.
No. Resilience plan is an
This is in
oxymoron.
practice. This is happening in practice. Proper planning
It's good stuff to
is
do.
very dynamic.
It's not our topic. Our topic is RE, replan.
Comment real quick.
Okay,
We're
quick comment. In the very early 60s, actually out of the late 50s, there's a famous paper by Gilbert White and others called The Levy Effect, in which the short-term adjustments created and constrained long-term risks, right? Adjustment to small floods created vulnerability to large floods. Very similar idea about what looks optimal. In the discussion as we go forward, I wouldn't mind if you sort of, not right now, but as we move forward, expand on the area of how optimality creates different points of brittleness. Because we have this pseudo notion about both the objectivity and the comprehensiveness of optimal approaches.
Right.
And so I'd like just as you in the discussion period.
And
come
it's
back to that.
fundamental in the papers and the videos and in the online class.
Yeah, but I'd like you to say
We've
something.
got
about it.
now 15 minutes for.